In this video, we're going to do a couple of trig optimization word problems. In the first one, we have a thin, rigid pole carried around a 90-degree angle. The widths of the hallways are given as 1.2 meters and 1.6 meters. On the diagram shown, the thin, rigid pole is this diagonal line. Now, we're not able to tilt that pole up or down, so we have to just carry it horizontally around, which means there's going to be a maximum length that we can actually safely carry around. Okay, so we need to come up somewhere with a variable, and what we're going to do, we're going to say that the variable is going to be theta. Now we know that that theta right there is going to equal that theta right there. So looking at, and I can say that the length of the pole is going to be this first part plus this second part. Okay? So looking at this first part, I can say that the sine of theta is going to equal 1.2 over L1, and I'm going to let L1 be the length of that first part of the pole, the top part. Then, similarly, using some more SOHCAHTOA concepts, I can say that cos theta is equal to 1.6 over L2. L2 is the length of the bottom part of that pole. Okay, so rearranging this first equation here, I can say L1 is equal to 1.2 over sine theta, and L2 is equal to 1.6 over cos theta. And so now we have an expression for the top part of the pole. We have an expression for the bottom part of the pole. Obviously, the pole itself is equal to the sum of those two parts. So adding them together is going to give us a formula for the length of the pole. So here's the diagram again one more time. And here's our math. L1 is equal to 1.2 over sine theta. L2 is equal to 1.6 over sine theta. So the length of the pole as a whole, as a function of theta, will be equal to 1.2 over sine theta plus 1.6 over cos theta. Okay, so moving on to our next slide, that's what we have. Now we're going to re-express this first part as 1.2 times sine theta quantity to the negative 1. And the second part is 1.6 times cos theta quantity to the negative 1. And that is going to provide us with an opportunity to do the chain rule. So we're going to say negative 1 times 1.2 is negative 1.2. We'll keep the base of the exponent the same and make the new exponent negative 2. But every time we do that chain rule, of course, we have to multiply by the derivative of what's inside the bracket. The derivative of sine theta is cos theta. Then we also take this negative 1, we multiply it by 1.6, we get negative 1.6 cos theta, but now our exponent is negative 2 instead, and we multiply by the derivative of what's inside, and that's negative sine theta. So now we've got this negative 1.6 multiplying ultimately that negative sine theta, that becomes positive. So we've put that in front. So this whole second part right here that I'm now circling, that's equal to positive 1.6 cos theta to the negative 2 times sine theta. And I've expressed that as 1.6 sine theta over cos squared theta. And the second part, and I know it's getting a little messy on your screen, but this new circled part, that's negative 1.2 sine theta to the negative 2 times cos theta. Or in other words, we're subtracting 1.2 cos theta over sine squared theta. So that is what L prime theta is equal to. Now we're setting that equal to 0. So if you set that left side equal to 0, what you can do is just bring the negative portion over, and doing some pretty simple algebra, you get 1.2 cos theta over sine squared theta equals 1.6 sine theta over cos squared theta. Now we're in a position where we can, as they say, cross multiply. We can say 1.2 cos theta times cos squared theta is going to equal 1.6 sine theta times sine squared theta. And that's what we get here. 1.2 cos cubed theta equals 1.6 sine cubed theta. So we're going to divide both sides by 1.6 and divide both sides by cos cubed theta. And when we do that, we get 1.2 over 1.6 equals sine cubed theta over cos cubed theta. Well, 1.2 over 1.6 is equal to 0.75. So we're saying 0.75 is equal to sine cubed theta over cos cubed theta. Well, sine cubed theta over cos cubed theta is the same as sine theta over cos theta quantity cubed. That's the same as tan cubed theta. So what we're really saying is that 0.75 equals tan cubed theta, or in other words, the tan of theta is equal to the cubed root of 0.75. Here's where calculators come in handy. Theta is roughly equal to 42.26 degrees. We know that theta has to be a number in between 0 and 90 degrees because we had perpendicular hallways. So that's what theta is equal to within that domain. And so now all we have to do is figure out the length. We'll go back to our original length formula, and I know it is quite messy now, but the original length formula was this one right here. And so what we do is we just sub in 42.26 degrees into there. So we get 1.2 over the sine of 42.26 plus 1.6 over the cos of 42.26, and roughly that's equal to 3.9. So given the circumstances we had, the longest pole that can go around that corner is roughly 3.9 meters long. For this next question, we are going to break out a prism. Hopefully we never actually have to use this in real life, but we have a description of a situation and we need to figure out the minimum length of ladder necessary. Okay, so we need to lean the ladder against a tall fence. When it says tall fence like that, it means it's so tall that we don't have to worry about whether it's tall enough. We can make it, for the purposes of our calculations, we can make it infinitely tall, so to speak. And then we're going to lean a ladder against that. Now, there's a 5-meter high wall right about here. So what we have is a ladder. The ladder is diagonal, and it's up against a fence. The fence is on the far left. There's a 5-meter high wall, which is this vertical wall right here. But this distance between this wall and this fence is 3. So imagine, hopefully this never happens, but imagine you're in prison and there's a wall and a fence, and your wish, let's draw it one more time. There's a wall and a fence, and your wish is to get a ladder long enough that you can lean it against the wall, and so that you can climb along that ladder, get to the fence, and then climb the fence and hop over. Okay? So we have to help you do that, so let's go for it. This is a description of the diagram. This is another rendition of the diagram. And so what we're going to do, we're going to let theta equal this angle right here, right down there. So if we let theta equal that angle, then theta will also be equal to this angle. And this bottom part of the ladder, which we can call that L2, that L2, we can say that the sine of theta will equal 5 over L2, which means L2 will equal 5 over the sine of theta. Now, similarly, looking at this top part, we'll call this L1. And we can say that the cos of theta will equal 3, because this adjacent length is 3. The cos of theta will equal 3 over L1. Rearranging that, we'll say L1 is equal to 3 over the cos of theta. So we'll have a formula for the top part of the ladder and a formula for the bottom part of the ladder. And that's what we have shown here, the exact same calculations. L1 is 3 over cos theta, L2 is 5 over sine theta. And what we're going to do now is add those together, make a formula where we add them together, and we're going to determine a derivative. And the derivative will be determined in much the same way it was determined a few minutes ago in the previous question. This first fraction can be thought of as 5 times sine theta quantity to the -1 Second fraction can be thought of as 3 times cos theta quantity to the -1. Determining the derivative of this first part means we have -5 sine theta quantity to the -2 times the derivative of sine theta, which is cos theta. The derivative of the second part gives us -3 times cos theta to the -2 times the derivative of cos theta, which is negative sine theta. This -3 times that -1 gives us +3, and we have, there should be a sine theta here. We're missing a sine theta, right where I'm circling now. That should say 3 sine theta. So we have a +3 sine theta over cos squared theta here. And then this whole second part is a -5 cos theta over sine squared theta. And again, so please note we do have that sine theta there. Now, of course, L prime theta is going to equal 0. So if I make that left-hand side whole thing equal to 0, that's equivalent to just moving this rightmost fraction over to the other side. So ultimately, really what we have is 5 cos theta over sine squared theta equaling 3 sine theta over cos squared theta. And again, we get another opportunity to cross multiply. We get 5 cos cubed theta equaling 3 sine cubed theta. And so dividing both sides by 3, dividing both sides by cos cubed theta, we get this expression here. So 1.6667 is roughly equal to tan cubed theta. So theta will be roughly equal to the tan inverse of the cubed root of 1.6667. So theta will be roughly equal to 49.85. Now, when we go back to our original formula for length with respect to theta, we can say L of 49.85 degrees. Instead of saying 5 over sine theta, we'll say 5 over sine 49.85 degrees. And instead of saying 3 over cos theta, we'll say 3 over cos of 49.85 degrees. And when we add those up, we get 11.2. And so we're going to need, it says longest, but it should actually say shortest. The shortest ladder that we need to get in this circumstance is actually going to be approximately 11.2 meters long. So if you ever find yourself in prison in exactly these same circumstances, where you're 5 meter high wall, 3 meters away, and you need to lean a ladder against so you can safely climb up the ladder, then climb up the fence, and then climb over and jump down and run to freedom. Should that ever happen, make sure you get a ladder that is at least 11.2 meters long.